Hey everyone. Now that you're familiar with the concept of limits, how they're defined, some basic examples of how to solve for limit of a function as x approaches a particular value, um, we're gonna look at an example of how to find the limit of a function. Suppose f of x is defined by x minus 1 divided by e to the 2x minus 1. Now find limit as x goes to 0 of f of x. That's the question. So how would we go about doing this? First, we try and check if directly plugging in the value of the value that x approaches, we plug that in. So here, that's 0. We first try and plug that in directly in the function to see what happens. So f of 0 is e to the 0 minus 1 divided by e to the 2 times 0, which is also 0, minus 1. What is e to the 0? That's 1. So we have 1 minus 1 divided by 1 minus 1, 0 by 0. That's an indeterminate form, right? As you probably already know. So 0 divided by 0, infinity divided by 0, infinity, these are not, we cannot determine what the value of these are, right? So now we need to simplify the function in such a way that we're able to compute this limit. Now, what is the denominator? E to the 2x can be written as e to the x, the whole squared, right? Because you have a to the power m to the power n is just a to the power m times n, right? And because we have that, we're able to write e to the power 2x as e to the power x, the whole squared, right? Now, in the denominator, we have something that looks like a difference of squares, a squared minus b squared. Do you guys recall what this is? Difference of squares can be written as a plus b times a minus b, right? So then we can write the denominator, well, the numerator remains the same. Here, our a is e to the power x, b is 1, because 1 squared is 1. So we have difference of squares. So that can be written as e to the power x plus 1 times e to the power x minus 1. Do we see common factors between numerator and denominator? We do. So we can cancel common factors. So we end up with 1 over e to the power x plus 1, right? So now we can do limit as x goes to 0 of f of x. We've now rewritten f of x as 1 over e to the power x plus 1. Now can we plug in 0? Of course. It's defined now. That's just e to the power 0 plus 1, which is 1 plus 1. That's e2. So there we have our limit as x goes to 0 of f of x. That's just 1/2.